To deter a cross-strait invasion, the U.S. military requires immense magazine depth. It demands deep stockpiles of precision weapons ready to fire on day one. But right now, global operational demands are actively draining those reserves. Middle East conflicts are consuming exquisite, long-range munitions at a blistering pace. Over 850 Tomahawks were expended in recent operations, a 30% reduction of the U.S. stockpile burned through in weeks. The industrial base produces just 80 a year. Replacing them will take a full decade. Air defense systems face the exact same pressure. Recent engagements have consumed half of the available Patriot and THAAD interceptor inventories. Production timelines are completely misaligned with the speed of modern combat. The industrial base cannot recharge these stockpiles as fast as commanders expend them. The United States cannot rely exclusively on high-cost, legacy platforms to project power. Mathematical attrition renders a strategy dependent on exquisite weapons unsustainable in a prolonged conflict. This dilemma is most acute in the Taiwan Strait. This narrow corridor creates severe spatial constraints. To defend it, the U.S. is shifting to deterrence by denial, creating a locked-down, impassable zone instead of a traditional battle line. Under this doctrine, the U.S. military does not need to fight for absolute maritime or air superiority over the strait. The sole objective is to deny an adversary the ability to safely move ships and troops across that space for a rapid amphibious assault. To execute this denial strategy, Indo-Pacific Command has developed an operational concept known as the hellscape. Shifting the objective from superiority to denial allows commanders to alter their acquisition math. They can trade the requirement for exquisite, slow-to-build platforms for disruptive, attritable mass. The physical layer of the hellscape relies on unmanned surface vessels and low-cost loitering munitions. Platforms like the Sea Shark 800 embody this critical pivot toward attritable hardware. This graphic compares the cost equivalent of one legacy missile against a swarm of unmanned systems. These drones deliver 90% of the legacy weapon's capability at roughly 10% of the cost. This hardware push extends to low-cost hypersonic cruise missiles, which compress engagement windows and allow commanders to strike fleeting targets before battlefield variables change. But cheap systems are lethal only if they know where to strike. They require a robust sensory backbone, known as C5ISR. Securing and denying this sensory network, counter C5ISR, is Indo-Pacific Command's top priority. Without space and information dominance, attritable mass is completely blind. To achieve this, the military fuses its classified satellite constellations with persistent commercial remote sensing data. This creates a continuous stare on the battlefield, rather than a periodic blink. Hardware and sensors provide the raw materials of deterrence. Without a central processing intelligence to direct the swarm, that mass is just uncoordinated noise. Artificial intelligence serves as the mandatory cognitive layer required to manage, optimize, and direct the hellscape swarm. At the tactical level, AI optimizes swarm behavior. It calculates how a smaller force of inexpensive weapons can effectively maneuver to neutralize multiple targets simultaneously. Strict rules of engagement govern this technology. A human operator remains on the loop at all times to ensure compliance with the laws of armed conflict. At the operational level, AI processes massive datasets to link complex joint functions, connecting command and control directly with fires and sustainment. If a firing decision is made at the front line, the operational AI immediately and automatically triggers the correct logistical reload pathway in the rear. At the strategic level, the military is employing large language models and agentic models to analyze highly sensitive incoming intelligence data. The goal of these strategic models is to mathematically calculate an adversary's second, third, and fourth order moves before they actually execute them. The speed of compute and decision-making allows a disorganized mass of cheap drones to function as a synchronized, responsive defensive layer. Every strategic plan in the Pacific is governed by a single geographic reality, the tyranny of distance. Technological advantages and AI swarms mean nothing without the logistical capacity to move energy, mass, and people to the front line across that 8,000-mile expanse. Moving this mass relies heavily on traditional naval assets. Amphibious transports and frigates remain the baseline requirement for bulk physical transport over open ocean. Transporting aviation fuel and diesel creates a severe bottleneck, and military logistics ships present highly vulnerable targets during an active conflict. To bypass this bottleneck, the military is integrating the volunteer commercial tanker program and civilian maritime shippers to sustain the fleet. Shortening these vulnerable supply lines requires allied burden sharing. Forward rotational basing, like facilities in Australia, places hardware closer to the conflict zone before fighting begins. Logistics defines the physical boundaries of Pacific deterrence, serving as the essential bridge between theoretical strategy and actual combat power. Advanced C5 ISR nodes on remote islands demand high-energy outputs. Relying on liquid fuel deliveries to power those radar arrays introduces a fatal operational vulnerability. To solve this, commanders are proposing a shift towards small modular reactors. These deployable reactors can generate project-scale, off-grid power directly at the forward edge. Implementing off-grid shore power completely decouples vital radar and communication systems from fragile long-distance supply chains. Once power and logistics are secured, the ultimate bottleneck remains: scaling the rapid production of attritable weapons. Advanced AI-enabled additive manufacturing allows the military to localize production and radically accelerate parts delivery timelines right where the forces are deployed. Exquisite legacy weapons are burning too fast globally. Building and deploying the attritable mass of the hellscape architecture is now a mathematical necessity. Achieving a successful denial strategy requires the defense industrial base to match the pace of global attrition by rapidly scaling autonomous mass.